Hello, my name is Jamie Ma. My student ID is 21982436. So, we're going to be solving for a velocity when this bucket is falling. And to do that, we have to first write down a potential energy before this bucket gets dropped. So while the system is still at rest, and that is going to be a energy is equal to mass times gravity times height. So this is going to be a potential energy only because this is before this bucket is going to get dropped. Once this bucket starts to get dropped, starts to go down, that energy is going to be converted to a kinetic energy. For the bucket, its kinetic energy is going to be half mv squared. And during this process, another energy is going to come to a play. It's going to be a energy from a reel's rotation that is going to be similar to half mv squared, but varied a little bit with inertia times angular velocity square. So according to a conservation of energy, we're going to set these two equal to each other. So potential energy equals 2 of the kinetic energy, and this is how we're going to set up the equation. Now, the question already gives us the value of all of these, except they do not give the value for inertia and angular velocity. So for the angular velocity, we're just going to do velocity over radius. And for inertia, we can actually solve for it by this formula. Inertia is equal to mass times radius of gyration. We can solve for inertia, which is 0.39. So given these two, we can plug in values that we already given here to all of these, and we will have all the numbers except for a velocity. So we're going to be isolating for velocity, and final answer is going to be 4.05 meters per second. So when this is being dropped, its velocity is going to be 4.05 meters per second. So the question also asks how we can decrease a velocity. Well, once we isolate for velocity here, we know that this is the approximate equation of this system for a velocity. So to decrease the velocity, we first have to break these equation down. Now, since the shape of the system cannot change, the only thing we can change is the inertia. So first thing we can do is increasing the mass of the system, which is going to be increase a denominator and it's going to decrease a velocity. The second thing we can do is to increase a radius of gyration, and this is going to increase a rotational inertia, which is going to increase the denominator and it's going to decrease the velocity. And the more effective one is increasing a mass of gyration, since they will do more than increasing a mass. Also, the mass exists at the numerator too, so it is not going to be that effective as increasing a mass of gyration. That is it for me. Thank you for listening.